All right, have you ever looked at a math problem and thought, wait, is that written backwards? Well, today we're going to crack the code on exactly that. It's a really cool, kind of strange, but super powerful way of writing calculations called reverse Polish notation.
So get a load of this. We've got a list of tokens, 2, 1, plus, 3, and then a star for multiply. How in the world does that equal 9? I know, it looks like total nonsense at first glance. But believe me, there's a really simple, kind of beautiful logic hiding in there, and we're about to pull back the curtain. Okay, so to get this, we really only need to learn one new rule. Just one. It all comes down to where we put the operator. You know, the plus, the minus, the times sign.
So on the left, that's the math we all know and love from school, right? It's called infix notation, because the operator's in between the numbers. But on the right, that's our puzzle, reverse Polish notation. And you can probably see the pattern already. The operator just moves to the end. So instead of 2 plus 1, you get 2, 1 plus. Simple as that.
And that, right there, is the one golden rule you need to keep in mind. The operator always comes after the numbers it's working on. That's it. That's the big secret. But, okay, knowing the rule is one thing. How do we actually, calculate an answer? Well, for that, we need a secret weapon. And our secret weapon for tackling these puzzles is a brilliantly simple little concept called a stack. This thing is going to do all the heavy lifting for us, you'll see. So, what even is a stack? Yeah, I know, it sounds like some techie jargon, but don't worry, it's super intuitive. Just picture a stack of plates, like in your kitchen. When you wash a plate, where do you put it? On top, right? And when you need a plate, where do you take it from? The top. The last plate you put on is the very first one you grab. That's a stack. That whole principle has a cool acronym, LIFO. Last in, first out. And you got to remember that, LIFO, because it is the entire engine that makes solving this RPN stuff work. The last thing you add is always the first thing you can touch. All right, time for the main event. We've got the rule, operator at the end. We've got our tool, the stack. Let's put them together and finally solve that puzzle from the beginning. We're going to go step by step, and I promise you're about to have that aha moment where it all just clicks. Okay. So we start with a totally empty stack. First up in our list is the number 2. Easy. It's a number, so we just push it right onto our stack.
Next, we see the number 1. Same deal. It's a number, so we push it onto the top of the stack. So now our stack has a 2 on the bottom and a 1 on top.
Whoa, okay, here we go. We've hit our first operator, the plus sign. This is our cue to do something. We reach into the stack and pop off the last 2 numbers. So we grab the 1 and then we grab the 2. We do the math, 1 plus 2 is 3, and we push that result 3 right back onto the stack. See that? Pop, pop, calculate, push. That's the magic move. All right, what's next? It's the number 3. We know what to do with numbers, right? No surprises, we just push it onto the stack. So now we've got a 3 sitting on top of another 3.
And here we are, the final item, that multiplication sign. We know the drill. It's an operator, so we pop the last 2 numbers off the stack. That's a 3 and another 3. We multiply them together, which gives us 9. And we push that final answer back onto our stack. And look at that, we're done. We've gone through the whole list, and what's left in our stack? Just one single number, 9. And that, my friends, is our answer. Mystery solved.
Okay, so walking through that by hand makes sense, right? But how does a computer pull this off? Well, the cool part is, it does it the exact same way we just did. The algorithm, the set of instructions, is just so simple. You just loop through all the items. Is it a number? Push it onto the stack. Is it an operator? Pop 2 numbers, do the math, and push the answer back on. You just keep doing that until you run out of items, and whatever's left on the stack is your answer. That's the whole thing.
And this is what I mean. It doesn't matter if you're looking at Java or Python or whatever. The code itself might look a little different. The syntax changes. But that core logic, that pop, pop, calculate, push idea, it's exactly the same. It's a universal concept.
And honestly, that is what's so cool about this. The real beauty of reverse Polish notation is how simple it makes things. You don't need any parentheses. You don't have to remember, please excuse my dear Aunt Sally, or PEMDAS, or whatever. The stack just handles all of that complexity for you. It's so elegant.
So right about now, you might be thinking, okay, that's a neat party trick, but why should I care? Well, it turns out this isn't just a brain teaser. This whole idea is actually a fundamental cornerstone of how computers think and process information.
I mean, you'll find this exact logic powering old-school HP calculators. They were famous for it. More importantly, it's a huge part of how programming languages figure out the math that you write in your code. It's also, by the way, a super common question in tech interviews. An even bigger picture, the stack itself is absolutely critical for how computers manage memory and keep track of what they're doing. It's everywhere once you know where to look.
So think about what we just did. We took what looked like a completely confusing jumble of symbols, and with just one simple rule and one simple tool, we figured it out. It kind of makes you wonder, right? Now that you know how to read math backwards, what other really big, complex computing puzzles could be unlocked with a tool as